Hello and welcome to the EMC Live webinar, Early Time HEMP versus IEMI Protection Measures. How are they similar? Different. My name is Belinda Stashikevich and I'm editor of Interference Technology, the creator of EMC Live. EMC Live is an online 3-day event featuring practical information and topics. This event will include roundtables, webinars, and videos on everything EMC related, and there's no cost to attend. Join us for our other webinars this week. This webinar is presented by Michael Caruso, Director, Government and Specialty Business Development for ETS Lindgren. Mike is a recognized leader in the RF shielded enclosure anechoic chamber industry with 30 years experience in account management, project management, and technical applications. Mike chairs ETS Lindgren's HEMP EMP product team and has been involved in a sales, design, engineering, and project management capacity for hundreds of projects involving high-performance RF shielding. This webinar is sponsored by ETS Lindgren. ETS is an innovator of systems and components for the detection, measurement, and management of electromagnetic, magnetic, and acoustic energy. They adapt to new technologies and apply proven engineering principles to create value-added solutions for customers. This webinar is one of many. To check out our others, visit emclive2015.com. A recording of this webinar and downloadable PDFs will be available on our website shortly. This webinar will be interactive. You will be able to ask questions and we encourage you to participate. Take a look at your GoToWebinar navigation pane, the box on the corner of your screen. If at any time you have a question, we ask you to fill out the type box and hit send. To make the screen minimize and maximize, click the arrow button. To raise your hand to ask a question or to report an issue, click the hand icon. We will present the topic for 35 minutes, followed by a 10-minute question and answer session. Now Mike will begin the presentation.
Thank you very much, and thanks everyone for tuning in to this webinar. What we're going to look at today is the protection measures for HEMP and IEMI and the similarities and differences between them. First, I wanted to start out with a couple of definitions. EMP, electromagnetic pulse, is a misused term, but it is a term that generally is used for as an umbrella term to define high altitude electromagnetic pulse, and that would be an electromagnetic pulse generated by a high altitude 30 kilometers or higher nuclear device in outer space. Note that there is no damaging effects, near field effects for radiation or blast. And the second part of it is intentional electromagnetic interference, which is disruptive to data and electromagnetic signals, and it's caused by the malicious use of electromagnetic weapons. And there's no detonation involved, so people don't get hurt, but the electronics have potential of being disrupted. So the potential damage from both HEMP and IEMI are very similar in that devices that rely on integrated circuits could be immediately disabled or destroyed. And unlike the cyber attacks where you have fingerprints, you can go back and tell that you have been attacked. The forensic analysis of your equipment would not show any signs of an EMP or an IEMI because the signals are just so rapid. We're talking picoseconds. The whole event would be less than 20 nanoseconds in duration. Again, much too fast for the recording devices in your computers to go ahead and record that. And it's important to understand that most electronic equipment that's off the shelf available these days is rated at about 10 volts per meter for immunity or susceptibility, as we used to call it in the old days. An EMP would create a pulse much higher than 10,000 volts per meter, up to about 50,000 volts per meter. So, and that would hold true for both the HEMP and the IEMI device, depending upon the size and the location of the IEMI device that might be in use. This chart is showing the waveforms for EMP, and for the HEMP, we are basically talking about the E1 early time EMP, and the intermediate and the late time are not something that we're going to be discussing in this presentation, because we're mostly concerned about the fast rise time and the very high levels of energy that would be created for the E1. And when we're looking at frequencies for the EMP, the E1 is generally found to be somewhere from around 10 megahertz up to 1 gigahertz for the HEMP, and for IEMI, that could very well be from about 400 megahertz to 10 gigahertz would be the highest frequency level of concern. So the similarities, there are some overlap between IEMI and HEMP in the E2 and E1 regions, and again, the IEMI has the potential of going up to much higher frequency levels. Some of the vulnerabilities of the systems is shown in this next chart, where for the E1, which is the center column that we're talking about here, you do have some power grid transmission and distribution control centers that would be affected. It's important to say that devices that are not connected to longer transmission lines or the power grid would have less vulnerability than the systems that are connected. So when we are putting together a protected facility, we are using power line filters with suppression devices that I'll talk a little bit more about in a later slide. This slide is showing two forms of shielded enclosure that get used for EMP protection, and these enclosures would be used for both the HEMP and the IEMI. On the left, what you're seeing is a welded enclosure, and essentially that is made up of a skeleton of support steel and welded plate that would make up the 6 sides of the enclosure. So the plate would go into place and it would be 100% seam welded to create the RF-free environment. The example on the right is a modular system, and this would be a bolt-together system that would provide the same levels of shielding effectiveness. But it is important to note that if you're looking at a government or military project and the specification is MIL Standard 188-125, that MIL Standard 188-125 only recognizes welded enclosures as the acceptable mode. So if you're looking at protecting a non-government, non-military facility, many times the 188-125 is referenced for performance purposes only, and not for the actual construction methodologies. This is an example of a typical door that would be used on an EMP shielded enclosure, and again, this door would be used for HEMP and IEMI protection. This is a classic knife edge door by which you have 2 rows of beryllium copper fingers that are housed in a recessed channel around the door frame, and then around the door panel itself you have a knife edge that goes into those beryllium copper fingers to create the RF seal. Again, a very classic, long time used methodology for creating RF doors, and very reliable for long term. Everything is precision made, and a door like this does require periodic maintenance to keep the knife edge clean and free from debris. In both types of enclosures, we do use waveguide air vents for getting air exchanges in and out of the enclosure. Could be for HVAC penetrations, or it could be for other means. Sometimes it's just used to promote natural convection to get some heat out or control humidity in the enclosure. The important thing to look at here is that, as in the earlier chart I talked about, HEMP, basically the high frequency component of HEMP stops at 1 gigahertz, whereas IEMI in some cases can get as high as 10 gigahertz. So in this chart we see that the 3/16 inch steel honeycomb provides attenuation at 120 dB for both 1 gigahertz and 10 gigahertz, and actually will take you up to 18 gigahertz. So this is a component to the shielded enclosure that would meet both requirements quite easily. The next component we're going to look at is the waveguide feed-through, and these would be used for fluid penetration. They come in insulated models as well. So this can be used for compressed air penetration, fluid penetration, sprinkler penetrations, and sometimes even fiber optics can be bundled and put through these penetrations. At ETS Lindgren, we use a 6 times multiplier to get the length of these penetrations. So, as an example, for a 4-inch penetration, we would supply a penetration that was 24 inches long. As you can see, at 4 inches with a 24-inch penetration, we would get waveguide beyond cutoff at 1.7 gigahertz, which would meet the HEMP requirements, but not the IEMI requirements if we were trying to achieve a 10 gigahertz or more commonly 6 gigahertz IEMI level. So we would have to go down to a 3/4 inch penetration maximum opening to be able to get 100 dB plus of attenuation at 10 gigahertz. What we're looking at in this photograph is actually is within an EMP protected facility. So put this up to give you an idea of some of the penetration challenges that can be had when looking at an entire facility for protection. We see some very large pipes here, and then some large pumps that would be connected to those pipes. The floor of this facility is shielded with a welded plate, whereas the walls and ceiling of this facility are modular. This photograph, although it looks a little funny, is a floor drain penetration, and it's a 4-inch penetration, and it's underground, but great care has been taken to have it fabricated so that the length of the 4-inch is a minimum of 24 inches of pipe for waveguide beyond cutoff. When we're looking at protecting a facility, we want to look at some roof-mounted equipment as well. And in special cases, we want to look at how the conduits are joined, how the junction boxes are created, and the various gasketing that's used on junction boxes, and the types of motors that might be used in these fan units. So what we're looking at here are radiator units, remote radiator units for the standby generators. This collection of 2 photographs is showing the very high current filters, HEMP filters for a facility. So these are both HEMP and IEMI filters. They have MOV devices in them. The photograph inset on the left is showing the covered units. So these are 1200 amp units, and there's 4 of them connected in parallel to create 2 penetrations of 4800 amps at 480 volts going into this facility. On the right, you're seeing an electrician starting to struggle with getting the cables into the filters and terminated so that they are paralleled. The cabinets that you're looking at on the left, you get a good idea of them. Those are 1200 amp cabinets, and they're 8.5 feet high, 4.5 feet wide, and 2 feet deep. So really quite large, and they weigh about 1,000 pounds apiece. And what you're looking at here is diesel generator exhaust. Specialty penetrations have to be done going through the wall of the shielded environment. This is an 18-inch exhaust that had to be increased to about 2 feet in order to reduce the pressure flows going through it and deal with the high temperatures. So very special application. But again, this exhaust system was created to provide cutoff up to 6 gigahertz in this case for an overlap of HEMP and IEMI protection. So with that, I've gone through the slides that I've prepared, and I guess we can open it up for questions at this point.
Thanks so much, Mike. We haven't gotten too many questions in yet, so we'd like to have a call for final questions from the audience. Please enter any last questions you may have in the navigation pane. We have received some questions on where to get additional information on this topic. There's a vast amount of content found on our website, emclive2015.com and interferencetechnology.com. You can also email us at info@interferencetechnology.com with specific needs, and we can direct you accordingly. Mike, we have a couple questions coming in. Please define IEMI. I think that you have, but maybe go over that again.
Yeah, the definition of IEMI is an intentional electromagnetic interference.
Okay. We'd like to ask for some more questions. If anybody has any last thoughts. Wondering maybe some people had attended the roundtable we had earlier, which went over some HEMP items, so maybe some of those questions might have been answered in there. Can we get the slides? Yes, we will have the slides available on our website probably by next week. Anybody else? Last chance to get some questions in. If anybody thinks of any questions afterwards, you can always email us at info@interferencetechnology.com. Mike, I'm not sure if you have any other thoughts.
Just the comments. What we have been looking at lately is a tremendous increase in HEMP, IEMI protection, especially for the critical infrastructure sectors as defined by Homeland Security. Looking at data centers, and we've had especially high interest from the financial institutions as well as utility providers. So it's a the protection of HEMP IEMI is something that has been thought to be a government issue for many years. And over the past couple of years, we've really seen a tremendous increase in concern from the private sector. So it's something that everyone should be looking at, and I highly suggest that at least it be addressed when you're looking at resiliency for your facilities and your operations.
Okay, we have a comment from someone in the audience that said, this is a minor correction. Mill Standard 188-125-1 does not require the shield be welded. The earlier version did.
Okay.
All right.
Very good.
Anybody else? Last call for questions. If anybody else has anything else they would like to ask, they can enter it now. Otherwise, we're going to wrap up here and thank everybody for attending. All right. And if you have any other questions, you can always email us again. Mike, thank you again for your time.
You're welcome.
And expertise. Asking everybody to join us next year. EMC Live 2016 will take place next April. Attendees, if you have any more questions, please send us an email. A recording of this webinar will be available on our website, emclive2015.com. We will also send a link to all participants shortly. Thank you for attending.